Hi, my name is HSLDA, and we're going to be covering what Chapter 2 is all about. Here's what I call a 30,000 foot view, or the bird's eye view of what the chapter is going to be about. And that way you can kind of keep this in mind as you study the chapter, so you kind of know the direction that you're going to be going in. A lot of times what students have trouble with is they get so focused down, so caught up in the minutia, the detail of all the things that they need to do, that they forget exactly what it is that why we're doing it. And so that's what the goal of these preview videos are for. So this chapter is mostly a review of concepts and terminologies that you've learned in earlier science courses, like your biology course or your physical science course. A lot of 8th grade and 7th grade science covers some of these topics and all of these kinds of things. One of the very important things that we're going to be covering in this chapter as well is the concepts of matter, and whether they have physical or chemical properties and changes, and the different responses they have to energy. The kinetic molecular theory is kind of a foundation to what other chemical theories are built on. So let's see. Let's go through this chapter, and I'm going to take a look at. All right. So we have matter, and whether we have the words like malleable or ductile or conductivity. So you'll need to understand those things. Here's one of my favorite ones, is talking about is a substance a pure substance or mixture, and you need to be able to classify that. If it's a mixture, it breaks it down into 2 additional categories. So you have matter, which is anything that takes up like mass, or anything that takes up space, and that would be matter. And so matter can be broken down into 2 additional categories, called a pure substance or a mixture. Now the mixture can be broken up into 2 additional subcategories, and that would be like a heterogeneous mixture or a homogeneous mixture. Now they're going to go over for you exactly what those are, and I guess I'll give you my little 2 cents on how I like to think about those. Think of when I think of homogeneous mixture, I think of well, honestly, and I know that this is, everyone kind of gets a little squirmy about this topic, but I think of the word homosexual. And homosexual is, things like a girl in love with a girl, or a man in love with a man. And I guess the reason why I think of that is only because in today's society, that is the only context in which we use the word homo, and it basically means same, as in same-sex marriage is homosexual marriage. And that's kind of where you have, if you're homosexual, you're attracted to people of the same sex. Well, a homogeneous mixture doesn't have anything to do with like sexual preference, but what it has to do with more is being the same. So if you have a mixture that is the same, and you can't tell 2 parts of that mixture apart, that is a homogeneous mixture. Whereas heterogeneous, or let's go with heterosexual, is someone who is what people would describe as straight, where they would be a man in love with a woman the way God designed it, or a woman in love with a man. It's really the same thing. That's interchangeable. And that is where you have different. You have a mixture of different things. Now, as it relates to chemistry, a heterogeneous mixture would be something like salsa. Whereas if I took 2 parts of salsa just randomly, I could have a piece of tomato and a piece of tomato, and I wouldn't be able to tell the difference. But there are chunks of like bell peppers, or jalapenos, or onions, and I can just take 2 parts of that mixture, the salsa mixture, and notice that, hey, those 2 parts are different from each other. So that would be some kind of mixture that's heterogeneous. I hope that makes sense. And yeah. Anyway, so that would be the homogeneous, heterogeneous mixture. And we have talking about elements and their formulas. We have energy, and talking about the conservation of energy. That's really important. And we have the law of thermal energy, And measuring temperatures, you're going to be learning about converting Celsius to Fahrenheit and all of that kind of stuff. And the states of matter, that's really important. Solids, liquids, gases, and plasmas. There are actually 4 states of matter, whereas most people learn about only 3 of them. And we're going to learn about converting from one state of matter to another state of matter. Now, we're going to be re-looking at that later on when we get into thermodynamics, talking about how solids go through sublimation to get through to a gas state, or it goes through from a gas state. When you have water forming on the outside of your cup, you're undergoing condensation to get to a liquid state. And so that's really important stuff. And I think that's it. We are going to be doing a lab. We're going to be doing a full lab write-up. Now, I have to warn you that we aren't going to be doing a lab in every single chapter. In fact, for the next 3 chapters, there's going to be no formal write-up labs. There might be a small experiment that you would do here and there. But this lab that we're going to be doing is paper chromatography. That one's a really cool one. That one's talking about how you can separate metal ions and the components of ink, and how to do that through a paper and the capillary action of the paper, pulling the water through the paper. So anyway, that's what chapter 2 is all about.